In the last video, we calculated the volume of a surface of a solid of revolution made by rotating a shape that was bounded by a parabola and a straight line. We rotated that around the x-axis and calculated its volume. In this video, we're going to see how the equation changes, how the formula changes when we rotate it around other horizontal lines. So let's go back to the worksheet. I want to start with this problem first, where we're rotating around the line y equals -2. So that's this line right here. So what's going to be different about this shape, about the rectangles that we're going to calculate? Well, when we rotate this around this shape, the rectangle that we're rotating is really this one right here and this one right here. So how do they change? How are these different compared to this video over here? Well, each one of them is 2 units longer because it's going down to the line y equals -2. So we're just going to calculate these in the same way. So we've got pi times the integral from, again, we're going from -1 to 2. And instead of being x plus 2, it's going to be x plus 2 plus 2. All right, so it's just going to be 2 more. We're still going to square the result that we come up with, dx, and v2 is going to be exactly the same thing, -1 to 2 of x squared plus 2 dx. All right, so once again, let me pop back to our graphing calculator and let it calculate these for me. Okay, and so all I need to do, and this is why I didn't do too much math there. All right, so that volume is going to be 63, but also remember I've got a pi sitting outside of that, that integral. And here I've got plus 2 going along with that. So that's going to be 30.6 pi. And then once again, to find the volume of the complete figure, I'm going to subtract the whole that's in the middle, the HOLE, from the big shape. All right, and so that's going to be a total volume of 32.4 pi cubic units. All right, and now the last question that they asked here is what happens if we rotate this around the line y equals 4? So we're rotating it around this line up here. All right, so how is this shape going to be different? Calculating it going to be different from the other one? Well, one thing is that the length of these sides is going to be 4 minus the shape, 4 minus f of x. And the other thing that's going to be different is that this time the parabola is going to be the outside shape. So this is going to be kind of an urn with a conical hole into it, instead of being a cone with a kind of a weird thing, a little cut in on both sides of it. All right, so this time V1 is equal to pi, our outside shape is equal to pi times from -1 to 2 of, and even though it's written as 4 minus x squared, we can still write this as x squared minus 4. And the reason is that we're going to square our answer. So x squared minus 4 squared is the same thing as 4 minus x squared, because one of these is positive and the other one is negative, but that negative is just going to get canceled out. So this is why the formula that you see on the previous page doesn't necessarily think about swapping the values of the 4 and the negative x. And that's the integral from -1 to 2 of x plus 2 minus 4 squared dx. All right, so once again, let's go back to the graphing calculator, and it's kind of easy to do if you've already done it once. We're just almost we're making just very subtle changes between the two numbers. So instead of being plus 2 this time, it's going to be minus 4. And this time, we're going to expect this to be the larger number, because this is the parabola is the outside shape at this point. All right, and so we see that. So the first volume is 30.6 pi, and the conical volume that's being dug out of it is 9 pi. And so the total of that is subtracting those two numbers. So 30.6 minus 9 is just equal to 21.6 pi. I should be clear that the examples that they used here, if we go back and look at the graph itself, you'll notice that the thing we were doing was either below the shape or above the shape. If we tried to rotate this around this line right here, this formula wouldn't work, because we got all kinds of weirdness going for the thing above the line and the thing below the line. But you will not be asked to think about that when you're calculating the volume of solids of revolution. So don't worry about that part. So this just gives you an idea of how you can use the formula that is at the on the previous page, and also how you can kind of make up the formula yourself as you're going along, just by drawing that sample rectangle like we did in this video and calculating what the length of that rectangle is. And that's just going to become the radius, which you have to square in order to find the volume, and then multiply your answer by pi. In the next video, we're going to talk about rotating a shape around the y-axis instead of the x-axis, and see how things change a little bit when we do that.